swords shouldn't be rocket powered. But Capcom and an artist called Frank Yang said fuck that and did it anyways. So, guess what I built? But the thing is, how do you actually make a rocket-powered sword? I want this sword to be as realistic as possible, but how do you get fire into a sword? I started with the idea that a barbecue creates the perfect fire, and it's somewhat controllable. But the flames, they just don't get big enough, to be honest. On the plus side, propane is really easy to get your hands on. So I'm going to use that as my fuel source for this project. I also found after some closer inspection of the game itself that it didn't just have one fire size mode, but two. So do I not only have to create fire in the first place, but I also have to create a controllable size of flame on the output, which when you look at the barbecue, you just twist a knob. But I have to do that automatically, and that's not as easy to do. So first off, the barbecue tubes are out. I gotta find something better. And I did. I found something online. They're called propane torches. Look at these things. I've also lived in Canada my whole bloody life, and these things are called de-icers or whatever. And I've never seen somebody actually using them in real life. So now I own 6 of them. And they can make quite the large fire.
This thing gets kind of toasty, so I'll have to work that into the design. There's definitely flames that come back through here. Look how big that is. Should really read the instructions for this thing. It's pretty cool. Never owned a flamethrower before.
So I quickly piped them all together and I got some results.
That's a problem. Those tubes are getting warm. Yeah, that's really warm. I didn't expect that to happen. I thought most of the heat was going to be contained in here.
So yeah, looking into it, air hosing isn't great for this application. Its melting point is about 85 degrees Celsius, and I think fire is hotter than 85 degrees Celsius, so we're going to have to swap that out.
After some thought, I think I'm going to use some copper pipe to run into the nozzle instead of this plastic stuff, because like, oh boy, that's like warm pretty far down. And this could actually work to our advantage. The Wyvern Ignition Greatsword actually has some piping along the side, so I could use this as functional piping that actually feeds into these guys. And a neat little feature is that there's 6 lines running into the back, and then 4 going up, and if you count 1, 2, 3, 4, 5, 6, there's actually 6 nozzles, and there's 6 nozzles in the real thing. So it's funny how much reality is built into these things from the get-go.
Everything aside though, I'm still going to use this plastic hosing in this project. It's rated for the pressure that the propane outputs, so that's all fine. It just can't be used close to the nozzle. That aside, we got fire, and we're headed in the right direction, so that's good. But as I said before, controlling them is going to take some thought. Normally, I just use a solenoid valve, but they only have 2 modes of operation, on and off, which is problematic for what we want to do in terms of creating fire in 2 different sizes. So I went online and did some digging, and I found something called pressure regulators. And these things are fantastic. Let me show you what they can do. In very simple terms, the knob on the top of the pressure regulator adjusts a spring and a plate. And depending on how tight or how loose that spring is, it allows gas to flow from one side of the pressure regulator to the other. And once it reaches equilibrium, as per whatever you tension the spring to, it shuts that valve. So it's really cool. It works really well for this application specifically. So putting it all together, I'm going to use 2 solenoids and 2 regulators. Regulator 1 and solenoid 1 will be low pressure. Regulator 2 and solenoid 2 will be high pressure to create the proper effect I'm going for here. I just have to turn one on and then the other, and it should work pretty well. All right, now that that's done, let's stress test everything. And it looks like we got some leakage, so let's fix those before proceeding. Probably a bad Y connector over there. Oh boy. I think I found the leak. New connector. No leak. Good. I also want to point out here that I did some experimentation with pink insulation foam to see if it could prevent the plastic from melting. Turns out, it works well for a short amount of time, which is perfect for this application. You may be wondering why I made the whole thing out of plastic though. I also decided to 3D print the entire sword because, well, you know, I love my 3D printer. I actually bought a bigger 3D printer for this project specifically. And yeah, I just wanted my CAD design to be translated right into reality so that I was getting everything built to spec automatically. It also allowed me to accurately route where the copper piping and the hosing was going to go. So that was definitely a benefit to everything. But as you can imagine, this whole thing was 3D printed and it was going to weigh a lot and it was a sword. And if you drop it into the ground, you might have some problems. So I came up with a new technique on how to solve this problem. It's something called TPU. TPU is a rubber-like filament that you can feed into your 3D printer that prints rubber-like material, which is really cool. Look at it, it's so squishy. And if I just slice my blade up into a whole bunch of different pieces, I can 3D print all of them and glue them together. And just to prove my point, here's a little demo of me smashing TPU attached to a 3D print into the ground. Works pretty well, eh? That's great news and all, but it still has to look like the final weapon, which means I have to paint it. So does it paint? As long as you're using a rubberized base coat like Plastidip, it works fine. Yeah, the seams are a little bit rough, but you know, it stays on there pretty well. Not to toot my own horn, but I think I just invented a new method for cosplay construction. It works really great on basically any type of sword out there. Okay, so now that the blade was printed and the body was printed and the fire was pretty much good to go, I just had to figure out a way to put it all together. Which is like, yeah, I designed it like that, but hey, things don't always go as you expect them to. And to get all the pieces together, I used a simple method called heat welding, which just melts the plastic together. Since it is a thermoplastic, you can just reapply heat to two seams and kind of sew it shut that way, which was pretty cool. And it actually holds its weight pretty well. For big pieces like this, I recommend using glue and the heat weld to make sure everything stays together. It also sands down really smooth as well, so that was a benefit to making it look like the actual sword with no seams. Once I had one side together though, I did a little lift test, let's call it, just to see how bad it was gonna be. And yeah, half of the sword weighed 22 pounds, so at minimum, the entire sword was going to be 44 pounds, which is a lot. Doesn't sound like a lot, but it's a lot. And to prove this, let's do some quick math. On screen now. Okay, so I made some errors at the time of recording and redid all the math. I first calculated how much torque was required to lift the sword from one end. I then rejigged the torque equation to solve for mass if you were trying to bicep curl it instead. Yeah, that number is right. Huge, but it's a rough estimation. Also, this is assuming you're trying to lift the sword like this. Please don't lift swords like this. Since you do lift a sword more like this, I'm going to roughly say that the equivalent mass for the bicep curl is half of what I originally mentioned. Yeah, that sounds about right. Still a lot to bicep curl though. Plus, you have two biceps in this case. Okay, now back to Captain to explain why the weight of the sword itself was a lot higher than the estimated 44 pounds. Yeah, you can see that number went up, unfortunately. Just because once all the accessories went on, plus the electronics, it ended up weighing a little bit more. Who knew that copper piping actually weighed a lot? But anyway, I started hitting the gym to, you know, try and lift this thing. And, well, I only got so far. And being the problem solver I am, came up with a backup solution. That is this thing here. Yeah, it's pretty straightforward. It's some 2x4s and a hingy thing on a pipey thing, and you put the sortie thing in there, and then you push down on the handle, and look at that, it lifts. There's definitely some physics going on here, but you know, it just works. So I appreciate that. Okay, but like back to the sword, because that was starting to be an issue. Like it is not going together. It's just, I designed it to go together and it's not going together. So yeah, for every plan you make sure you have at least like 3 or 4 different backup plans, maybe 5, just in case. Because holy geez, did I need it in this case. I still ended up with a slight gap in the sword, but you know, I was willing to take it. All of the hosing still worked, which I checked as I went, so that when this thing got glued together and a pipe wasn't working for whatever reason, I wouldn't have to try and pry it open, because construction adhesive is very strong. I do not recommend trying to take anything apart after it's been construction adhesive together. So that was a whole problem in its own, but I could solve the gap issue, no problems there, bada bing, bada boom. And those gaps were easily filled with some 3D printer filament that I just melted with my soldering iron, as well as, you know, some more construction adhesive and Bondo, you know, because why not? Just a slurry of every chemical known to irritate eyes and skin. And after months of just preparation and design and all that, I actually started to feel good about this project. Like it was coming together and things were working. The sword almost ready to be primed, sanded, and painted. It was just a matter of designing and 3D printing the accessory pieces. Oh wait, what's this? And they're already done? Fantastic. It's like those TV kitchens. You just pull out the tray. It's already done. Well, since they're already done, we may as well just paint everything. I start by doing a rough sand with about 100 grit sandpaper with my palm sander, and then a finer sand with a 400 grit paper and block. For hard parts, I use a primer filler combo. And for the squishy TPU, I use the Plasti Dip, as I mentioned earlier, as it claims to be flexible primer paint. After, it was a matter of layering the metallic paints down first, and then applying any colors required for the various pieces. I ended up going back to Canadian Tire and buying a whole bunch of different spray paints. I ended up getting a metallic blue spray paint for cars, and that worked really nice. And I ended up using copper spray paint for everything else. It turned out pretty shiny. If you do want me to do an in-depth video on how I paint things, let me know in the comments below. Oh, and while you're down there, don't forget to like and subscribe. With everything painted, it was just a matter of doing some assembly and getting things to work and redoing things over and over and over again. We eventually got to the point, so now, without further ado, the grand reveal. As always, I've been your captain, and I hope you enjoyed the journey.